Hello everyone. Still people are joining. So let's wait for another minute or two and then we'll start the session. All right. So hello everyone. Good evening. My
Good
name
evening,
is
sir.
Vikas Joshi and I'm going to conduct today's open session, which is for week 10. So whoever has a doubt, please raise your hand and we can have a discussion. I mean, the same pattern which we have been following for last 2 months or so. So anyone has any doubt? No doubts? Am I audible? Hello?
Yes, sir.
Yes, sir.
Okay. Yes, Karthik.
I have a doubt in lesson lecture 10.4
Okay.
about the dictionary. Like you have that dictionary which is nested to 3 levels, right?
Okay.
So I just want you to explain, like, I mean, how will be the keys? I mean, example of how the dictionary is constructed with the pseudocode.
For that specific pseudocode or in general?
That specific pseudocode, how this dictionary is constructed.
Okay, let me have a look at that particular lecture so that maybe I can help you better.
Please.
Yeah, okay. It's better to refer slides. Lecture 10.4, right? That's what you
Right,
said?
sir. Right, sir.
Okay. Okay, it's age labeled graph. Okay, understand. Okay. Do you remember which pseudocode you're talking about? Is this the one or some different
It is
one?
direct IJT equal to D. The next one.
Okay.
It's really a dictionary. Yeah.
IJT is equal to true. Okay.
Yeah.
Okay, fine. Just give me a minute. Let me see what that I, J, and T are.
Okay, sir.
Yeah. Or if you remember that, you can tell me. It will be even faster.
Sorry, sir.
Do you remember what I, J, and T are?
I, J, and T are the. I mean, it's a
sir.
adjacency matrix. Which maps
okay, I and J are
directly.
stations. So the adjacency matrix is for the stations. Direct is a matrix, right?
Yes.
Where
sir.
we are finding whether there is a direct train between stations I, J or not.
Yes,
If that
sir.
is the case, then T is a train, and then what we are stations, trains of T start and end. Okay, then T is true. Okay, got it.
So we can even map distance also for this particular stations, right? It can be anything. The concept can be broadened, right?
Yeah. Right now, as per this pseudocode, whatever I'm seeing in this slide, we are not, mapping the distance per se. We are just saying whether train is there or not. I mean, as you can see, just saying true, right? I mean, instead of that, we can replace that boolean with some distance in kilometers or something of that sort. That's also possible. But as of now in this pseudocode, that's not happening. You're just saying whether train is there or not. Okay. So, okay, I'll tell you what is happening. So, okay. See that this was the line, right?
Right, sir.
Okay. So now let's see what each part over there is. What is I?
I is station.
Starting station.
Starting station.
I is the starting station. Okay. Okay, fine. Let me see whether it is specifically I. Okay, yeah. I is the starting station.
Sir, excuse me, sir. Just now I joined from maths class.
Yeah. Okay,
Sir,
so
is it an activity question, sir?
no, this is not activity question. This is from one of the lectures we are talking about.
Okay, thank you, sir. Sorry to interrupt.
So if you have a doubt, please raise your hand. Maybe I will take your question next.
Okay.
Okay.
Right, sir. Thank you.
Right. And what T is a train.
T is
right?
a train name
T
or
is
the
a
number.
train. So whenever I say I as a starting station, that means we are actually having a station, right?
Right, sir.
A station name, maybe Chennai,
Right, sir.
Mumbai, Delhi, some name, right? And when I say train, I'm talking about train number.
Right, sir.
So T will be a number, right? A train number. Whereas IJ will be strings.
I think even IJ is a code for the station number.
IJ is
code for the station. Because
Yeah, they have
coded-
already, run a loop to map the station names to the,
Code.
to a while.
Okay, yeah. So it will be also a number allotted to that particular station.
Right.
Yeah, I see it. It's there in the previous slide. Okay.
Yeah.
Okay, fine. Anyways, so for simplicity, let's consider I and J as strings. Okay, so that it will be easier for me to explain rather than taking some numbers, random numbers 0, 1, 2, 3. Okay.
Right.
So I'll just tell you how it will look. So this direct dictionary will, let's say I is as a station, right? Let's say it is Chennai. Okay. So for that particular station, you have another dictionary, right?
Okay.
So let's say I'm checking between Chennai and Mumbai. So that's a one possibility.
Okay.
In that, again, there is a dictionary. Why this dictionary? Because there is a possibility of multiple trains running from Chennai to Mumbai.
Okay.
Okay. Let's take number 100. Just assume there is some train number 100.
Okay.
And it actually runs from Chennai to Mumbai. And for this train number 100, starting station is Chennai and ending station is Mumbai, as per the card what we have. And if that is the case, we will write true. Right?
Okay,
there is a possibility that there is another train which runs again from Chennai to Mumbai.
Okay, got it, sir.
Right? Apart from that, now this is the first dictionary which is there for Mumbai. Right?
Okay,
After
sir.
that, I am putting one more station, maybe let's say Delhi. Okay.
Okay.
Now again, there is a still, if you see, just follow these brackets carefully. This is where Mumbai ends.
Okay.
So Delhi, we are checking against Chennai. So starting station is Chennai, ending station is Delhi. Again, for this, maybe there is another train. So this whole thing, this much is against Chennai. This much, whatever the highlighted value I'm storing against key Chennai.
Just a second, sir.
Yeah.
Okay, sir.
Understood till this point?
Yes, sir.
Okay. Now, after this, I can have maybe another station. Maybe this time, now let me take it other way around, right? Now I will add Mumbai. Now you might see that why the keys cannot be duplicated, right?
Right.
But this Mumbai is inside, it's at the second level of dictionary, whereas this Mumbai is at the top level. That is allowed
Okay.
now, right?
Right. Yeah.
Earlier, we were checking trains from Chennai to Mumbai and we found 100 and 200. Now, I am finding trains from Mumbai to Chennai.
Okay.
Right. And once again, for this, see now Mumbai, Chennai, there is another dictionary. Now, as per our data set +1, you will give the return train, right?
Yeah. 101 for.
So let's assume 101. Similarly, you get 201.
Yeah.
So this is what the particular dictionary will look like.
Great, sir. I understood now.
So
Sir.
at top level, you will get all stations. Let's call it first level. Second level, again, you will get all stations. And in third level, you will get those trains which are actually running between those two stations, a combination of IJ, every combination of IJ to be precise.
Okay, sir. Got it, sir. Got it. So now, see, if this is the pseudocode, for example, this is my doubt. I don't know whether it is relevant to this, lesson or not, lecture or not. If I want to maintain two labels,
okay,
for this particular edge, is it possible, sir?
Yeah, you can create a list, right?
Okay. So how does that list will look like, sir?
So for example, for this train 100, right?
Okay.
Right now, when I say true, that means there is a train. That's all information we get. We do not get anything beyond that, right? Instead of that, let's say I want to know what is the distance between these two stations.
Yes.
Let's say 1200 kilometers. I don't know whether that's the case or not, but let's assume 1200 kilometers.
Okay.
And maybe second information I want to say how much time it takes.
Okay.
Let's say in terms of hours, and let's say 24 hours.
Okay.
That's
so which means in this case, since both these values or even one value is present, it obviously means that the train is true.
Correct. See, if in fact the way pseudocode is there, we are adding only those trains where there is a direct. If there is a direct train, then only we are adding those trains. We are not adding all trains for every pair of stations. We are adding only those trains for which Chennai is a starting point and Mumbai is an ending point. So you will not get all trains in this dictionary. You will get only those trains in this dictionary which are actually running between those stations. So if you do something like this, right?
Yeah.
For example, like keys of direct of, let's say Chennai, Mumbai, comma, let's say 100. It will give you true. That means this train number 100 actually runs from Chennai to Mumbai.
Okay.
But instead of this, if I do 101, it will give you false because it is not running from Chennai to Mumbai. It runs from Mumbai to Chennai. Then I have to exchange these two keys.
Is key, right, sir? Is key.
Yeah, sorry. Is key. Is key.
Okay.
Right. So this particular thing will give you true. So if you want
list, it will give list.
No. Is key will just tell you whether this particular this thing is a key inside this or not, which is there, right? So who asked Karthik, right? So Karthik, if you just want to know whether 100 number train is actually running from Chennai to Mumbai or not, this line is enough for you.
Okay. So it is as good as saying is key of Chennai and Mumbai equal to 100 is as good as saying as command.
No. You cannot say equal to 100, right? Because actually it returns either true or false.
Okay, so it's a Boolean.
It's function. A Boolean, right. Okay. So you just put it inside if and you're sorted. You will know whether 100 is a key. Is a train number, train running from Chennai to Mumbai or not, right? And if you are happy with that much information, then this will work. But if you also want to know, okay, train is there, but now beyond that, I also want to know what is the distance between what is the distance for traveled by that train and what is the duration, then this is not enough. Then in that case, you will not do this. You will do this 100, and this will give you a list.
Okay, sir.
And then you can do first of L and last of L, which will give you 1224.
Okay. Just one
And
more
if you want to
question
store
before
more
I.
information, you can add third value also over here if you want to store something else. Maybe
Okay.
days on which the train is running, something like that. Whatever.
Okay. I will just wind up with just one more question. I
Yeah,
just
sure.
want to know if you can replace that L by E's keys.
L, okay, the one what we had earlier, right?
Yes, E's
Okay.
keys.
Sorry. Is keys, yeah.
Okay. Now if I say in square brackets,
Yeah.
in square brackets, yeah, 100 in
Uh,
square brackets.
yeah. Okay.
I
In
want
square
to say
brackets, hundreds. Okay.
yes, and comma 200. So is this error or it will return false?
It will return false.
Okay. So
See what
pseudocode
is
will-
okay. Let me see. Hold on. 200. You are checking inside. No, it's an error actually. Because in
Okay.
order to do this, the first
Yeah.
part of the first parameter of function has to be a dictionary.
Okay.
Right. What is happening? You are checking whether 200 is a key inside this or not, right?
Yes.
But this highlighted part is not a dictionary in the first place. So it will give you an error because your first parameter doesn't fulfill the requirements of this particular function.
100 is not a dictionary, that's why.
No, not 100. This highlighted part is not a dictionary. What is the value of this highlighted part? It's a key. Sorry, it's a list.
It's a value.
It's a list.
Yeah, it's a value.
It's this list.
Yeah.
And in you're not supposed to execute each key function on a list. So it's an error.
Okay.
But instead of this, maybe I make it a dictionary. Right?
Yeah.
And maybe let's say kilometers and hours. Now it will give you false because 200 is not now 200 is not a key inside
Inside the 100 dictionary.
inside this particular dictionary.
Okay.
In this case, it will not give error, but it will give you false.
Okay. Sir.
And now it's a 4-level nested dictionary.
Okay, sir.
Okay.
This is done, sir.
Okay.
And I have one doubt regarding the graded assignment for week 9.
Okay.
Frankly, I have not seen the solution yet. So
Okay.
what do you advise me, sir, to see the solution and come back to you if I have doubt, or you can explain it?
Yeah, I think that's better because there are few more people waiting. So
Okay, sir.
let me give them a chance. And if still you have doubt, we can get back to that.
Okay, sir. I'll do that, sir. Thank you very much, sir.
Okay, great. Thanks. Okay. Next is Dev.
Yes, sir.
Yeah, tell me. What's your doubt?
Sure. Actually, the question you were explaining right now, even I tried to understand it very much, but I can't understand. It's the same direct function was in graded assignment question.
Okay.
So the graded assignment question, I will tell you. Just let me go to my screen.
So the question. Which week? Week 10.
Week 9.
9. Okay. Is it closed or it's still open? I don't remember the dates.
So they are closed, sir. Yesterday.
Yesterday. Okay. Then we can discuss it. Okay. Tell me.
Yes, sir. So the 14th, sir, from the question number 14. Also, sir, question number 13, I have a doubt, but we will come. I will like to come to later. But question number 14 and this 15 question, I can't understand what the questions are. I can't understand even a single thing in this.
I don't see any direct that particular dictionary used here.
Sir, in the 16 question there is 15 question there is BRC equals to direct RC.
Okay. But your doubt is with 15 or 14?
14, 15 both, sir.
Okay, but 14 is different one. But okay, have you referred the solution? It's there, right? Yeah, it's there. Have you gone through the solution?
I have not gone through the solution yet, sir.
Maybe you should.
Okay, sir.
There is no point repeating same thing which is already there, right? Maybe just
Okay.
go through it. I mean, anyway, we have just started the session. You still have more than 1.5 hours. Just go through it. It's still doubt is there. You ask me, I will explain again.
Okay, sir. Okay,
I
I
mean,
will ask some
you
to
were
later.
there. You were there throughout the explanation of what with the direct matrix, whatever I was talking about for last 10-15 minutes. You were there, right?
Yes, sir. I joined for 8:05. I was there for the almost most of the time.
Okay, okay. Then
But
maybe
actually-
with that direct, now I believe you understood what the direct matrix is, right?
Yes, sir. Means it's basically about if the stations are correctly connecting to it directly come true and all. I can't.
Yeah.
uh,
Okay,
this
maybe
is-
then just have a look at the solution once.
Yes, sir.
and
I will
if
look
doubt
at
is
it
there,
because
I'll come back to you.
Okay, okay.
Sure.
Yes, thanks.
Okay, great. Thanks.
Sir, if it is
Okay.
about 15th question, then there is one thing, sir, that is also related to 16.
Uh-huh.
It's something like they both contradict. The
Oh,
answers
really?
given for 16th one and the 15th one, sir. Like according to me, what I have observed.
Okay.
It is
Again,
because,
have you looked at the solution?
yes, sir, I have looked at the solution.
Okay. And still you feel they are contradicting?
In the 15th question,
Uh-huh.
first option is also the answer actually, in which it is like B of RC is equals to 1, then exit the loop. Yeah, this one.
Mhm.
So if it exits the loop for this for the first if condition itself, which
Mhm.
means there is a direct train for it, which is not like which isn't a sequence, which there exists no sequence for it in that case.
Mhm.
And if this is the case where no sequence exists, then in the 6th one you will get answer 20, sir. 16th one,
Okay.
because
Yes, the answer for 16 should be 20 according to me also.
yes, sir, because same node cannot be reached again and again.
Same
Why?
If it
station
starts from
cannot
there, then
have.
it won't come back to the same thing itself, right?
Okay. Well, what's the problem in coming back to same station again?
No, sir. They've mentioned non-empty sequence of trains and non-empty sequence of edges,
Okay.
which means there exists more than one edge from starting node to ending node.
Mhm. Okay, hold on. I mean, I don't remember the question as well as you guys are remembering it, but let me go through the question first so that maybe I can tell you better. So
Yes,
who
sir.
was asking? Dave, maybe are you there?
Yes, sir. I'm there.
Yeah, so maybe let's do 15, 16 now. I mean, multiple people
Yes,
have
sir.
doubts with
Yes,
it.
sir.
So let's do 15, 16. You go through 14 after this, and maybe if you still have doubt, come back.
Yes, sir. I'm seeing the great assigned solution. Okay.
Okay, so maybe just keep that on hold and let's go through 15.
Okay. Okay. Okay.
Okay. Yeah. Okay, so what we are assume there are n stations in the train data set, index 0 to n minus 1, consider. Okay, so this is what you are talking about, right? Station J is reachable from I if we can find a non-empty sequence of trains that can that can take a
That takes a
passenger
passenger
from
from I to J.
I to J.
Yes,
Okay,
sir.
so this is means, I mean, this is a reverse train in that sense, right? So if there is some sequence which takes you from I to J, then you can assume that J to I also exists, right?
Yes, sir.
Okay. In other words, J is reachable from I.
No, sir. J is reachable from I does not mean that I is reachable from J, sir.
No. That's
I
what
think-
the what the statement says. Stations J is reachable from I if we can find a non-empty sequence of trains that take a passenger from I to J.
I to J. So J is reachable from I, that is okay, but I is
But-
reachable from J, that's a different sequence of trains. That
Correct.
may
So
or may not be
what?
this also.
So that is the point, Siddharth. What we are saying, if we can find such a sequence, right, to reach from I to J, then J is also reachable from I.
Ah,
No, sir.
J is
Sir,
reachable.
Yeah,
I to
okay, okay.
J
J is
only.
reachable from I, not other way around. Okay, okay, fine,
Yes, sir.
fine. Yeah, sorry, I misread. I mean, here the sequence is different, here sequence is different, so I just got confused. Okay, I got it. So anyway, we are going from I to J if there is a non-empty sequence of trains. Okay,
Yes, sir. But they didn't
that is
mention
that one more hop thing.
They didn't mention that I should not be equal to J also, which means both I and J can be same stations. If it is same stations according to this code, I mean the answer, providing R and C both are of same stations, if that is equal to 1.
Yeah,
which means there is a node from the self, which means there exists a node for self to self itself.
Yeah,
No,
there
it
is a
won't be
possibility.
possible.
See, listen, I will tell you. Initially, if I and J both are equal, right? That means we are talking about that principal diagonal, right? It will be 0, right?
Yes, sir.
As per the direct matrix, it will be 0.
It will be 0.
But later on, we might find some train which is going from A to B and then maybe coming from B to A. Because of that, the same thing, I mean, what we call it, if I and J are equal, then it might become 1. After maybe 1 hop or 2 hops, something like that, later on, it might become 1. There is a possibility, but initially, definitely it will be 0. See, because as per the code, we are never checking whether R and C are equal or not, right?
Yes, sir.
So plus, if they are equal, then the sequence of trains will be empty. Initially, if
initially it will be empty, but later on,
later on
that's possible, right?
Sir, but in this case,
yeah.
But in this case, you will have to revisit the station more than once.
Okay, so
if you're revisiting the station more than once, mathematically it is not it doesn't come under a path, because if you are calculating a distance from S0 to S1, I mean that is station 1 to station 2,
right?
There is some distance between station 1 to station 2,
right?
If you're writing a matrix for station distance matrix, if you're writing a matrix for distance, then from self station to the same station, there comes 0 for it,
right?
We can't write it like it takes maybe some two hops or 3 hops and again comes back to the same station, which has the distance again, which makes no sense in that point,
right?
So when it isn't correct in that point, it should be like, even in this way, there should not be a path from there should not be edge from self to the self station itself. That's what I meant.
There is no direct edge.
There is no direct edge. See, I will tell you. Okay, Karthik, the point is, we are not saying that there is a edge from station X to station X. That's not happening. There is no self loop. But there is a train. There are. I mean, eventually there is a possibility, right? Like this, what you have here. We are not saying you can go from 0 to 0, but one person can keep going and going, and as per whatever trains we have, yes, there is a train from 4 to 0. So one person can actually come back like this with 4 hops in between, right?
Yes,
so
sir.
Logically, the way computer works is what? With that one more hop, what happens? What this one more hop do? It checks whether there is a path from some station X to station Y with some intermediate stations or not, right?
Yes, sir.
We are never checking whether that X and Y are equal. I mean, in this case, R and C are equal or not.
Yes, sir.
And it's very much likely to have this kind of a scenario.
Yes,
we are not saying there is a train which starts from 0 and ends at 0. That's not what we are saying. There are sequence of trains because of, I mean, due to which you can end up back to the original station.
Yes, sir.
Right, which actually happens even in actual trains running in India or anywhere. That's bound to happen, right?
Yes, sir.
Right, that's the point. So it's absolutely natural thing. I mean, it doesn't make any sense to have a train from 0 to 0. That I understand. But some combination of trains might take you back to the original station, which is very natural thing to have for trains, right?
But the thing is, when the train ultimately want to come back to the same station, why would it have to take another round? Like it has to go to some other station and come back to the same station.
It is not the same train.
It is
some different train.
See, I'll tell you what is happening. So, Karthik, right?
Yes,
Karthik, where you stay?
I stay in Bangalore, sir.
Okay, you stay in Bangalore, right? So let's assume 0 is Bangalore, right? You started from Bangalore, you went to, let's say from Bangalore to maybe Belgaum, right?
Okay.
You're going up north in the country, right?
Yes, sir.
So you went to Belgaum. From there, maybe you went to maybe let's say maybe Mumbai, okay?
Yes, sir.
From there, maybe you went to Bhopal.
Yes, sir.
From there, maybe you took a station back to train to Hyderabad.
Mm-hmm.
And there is a train from Hyderabad to Bangalore.
Yes, sir.
It's very much likely to happen. I mean, if
Yes,
you check actual calendar, schedule of trains in India, you will see such trains, right?
Yes, sir.
So that doesn't mean we are not saying there is a train which starts from Bangalore and ends in Bangalore. That's not what we are saying. Because of this combination of 5 trains, you might end up back to the original station.
Yes, sir. Then it means it's more like if there is a possibility, the train can come back to the same point again and again. That's
Not same train, not same train. That's what I'm saying. You took some 5 trains to come back to the same station.
I've come back to the same station. The thing is that like revisiting the same point again and again makes a path again.
Yeah, it's a path, right? It doesn't make any sense for human brain. I understand that. But there is a path from station X to station X via some 4 or 5 trains or whatever, right?
There is an error in the code. You have to first ensure that when you are comparing I to J, I should not be equal to J. That you have to compare in the code.
No, not necessary. Why you want to compare? That's what. If you compare it, then this particular structure you cannot have in the matrix.
No,
yes, sir. I got it, sir.
See, if you actually compare that whether R and C or I and J are equal or not, then this 4 to 0 train you cannot add.
Yes,
I mean,
sir.
then this 0, 0 matrix, I mean, that M of or whatever, the direct of 0, 0.
If we add that condition,
Yeah.
then for every row, you will have only 4 entries which are 1 and 1 entry will be 0. For every row in the matrix,
Yeah.
all 4 entries will be 1 and 1 entry, the self entry will be 0.
Yeah, we don't want that. That's the point. We don't want that because as we just discussed, right? There is a way to reach from.
Nobody would want to know whether I can come back to the same station from the same station. We don't want to know that. We want to know whether we can go to any particular station from this particular station or not.
Agree. Absolutely. I agree that. See, that's what I'm saying. At human level, whatever you say is correct. You don't want to know that, right? But the way that one hop procedure, which is explained in the lecture or anywhere else, right? What is the job of this procedure?
To know how many hops are there between two.
I mean, in order to reach from station X to station Y, I mean, is it possible with some hops or not, right?
Or hops or not, yes, yes.
Right. That's all this procedure is supposed to do.
Yes.
And that's what it is doing.
By the way, sir, in this code, in this above code,
yeah,
the number of hops should be initiated to 1, right, sir, in this? Because for hops equal to 0, we are executing one more hop. We are executing one more hop. For hops equal to 0, we are executing one more hop, and then we are incrementing hops to 1. So I think the hop should be initialized to 1 first. So
but the maximum is n-1, na?
Yeah, we are starting from 0 to n-1.
Maximum number of hops will be n-2. That is right.
No, maximum will be n-2 because so suppose you take 3 trains where n is 3, then the hop can be only 1, na?
So between
if the maximum is n-2, then the total number of hops will be n-1, na? Because 0 is 1, so n-2 is
hops will be n-2. Because if suppose let's say there are 5 stations. Right?
You're taking the value of hops. I'm saying the number of hops. The total values that hops will take is n-1, but the maximum value hops will take is n-2.
No. Total value will also take n-2. The maximum can.
Suppose we have 5 stations. How many hops you will take to reach the final station?
3 hops.
Only 3 hops. So it is n-2. So a hop should be initialized to 1, I think, there in that code.
Okay. See, first for that, you have to check what is happening in this pseudocode, right? What we are talking about? We are talking about trains, right?
Yes, sir.
Are we talking about stations or trains?
We are talking about.
We're talking about stations only, sir. Direct matrix contains if there is a path exists from station 1 to station 2.
Correct. But see, when we add age, when there is a train, right?
Yes, sir.
Right. So the point is there is a train from 0 to 1. That's why there is a age.
Yes,
right?
Sir. But that's not a sequential.
For direct, if there is a direct train, then we add 1. Otherwise, we add 0.
Correct. But what does this mean? How many hops are there between 0 to 1?
0 hops.
0 hops.
0 hops, right?
Yes.
So as per that code, what we are doing? We start with 0 hops.
0 hops.
Right? We start with 0 hops.
But
so whenever
for hops equal to 0, we execute this one more hop once.
So right. So what is happening? Listen. So that just give me a minute, okay? What is happening? We are. That's why we started with 0 hops, okay? Because there is no hop between 0 and 1, right? We started with direct matrix, correct? And after that, we called this one more hop, this particular procedure once. After that, we got some result. And this particular result is with 1 hop. That's why we incremented by 1. All right?
Yes, sir.
Next time, we call this procedure again. Now, this time, this B was with 1 hop. Now, we executed this procedure. Now, this B is with 2 hops. That's why we incremented 2.
Yes, sir.
Understanding?
But the increment should be done first because we are checking with less than n-1. If we are checking and then incrementing, then this n-1 should be n-2, sir.
See, listen, this particular hops variable has to be incremented under this while.
Yes, sir.
Are we using this anywhere else?
No.
So what is the significance of this variable?
It is telling you the number of hops, number of times this one
number of times this should get called, right?
Executed. Yes.
Right. So in that sense, how many stations we have over here? 5.
5.
So how many times this particular loop will execute?
3 times.
Yes, sir. 3 times. Because 5 minus 1 is 4 and hops is less than.
It will be executed 3 times.
So 4 times, because for 0, then 1, then 2, then 3, then 4.
That is why I'm saying, sir, hop should be initiated to 1. Hop should be initiated to 1.
See the problem that you normally count from 1 to 2, 1, 2, 3, but here in computing we're counting from 0. So 1 is corresponding to 0. Similarly, like 4.
Direct is corresponding to 0 hops. Direct matrix is corresponding to 0.
Correct. So for example, if you have 5 stations, if you have to go to the 5th station, you will take 4 hops.
No, we are taking 5th station. We take only 3 hops, sir. Because there are 3 stations in between the first station and the last station. So we are taking
in the
3
fourth
hops.
Listen, guys, just listen. Hold on. Let me complete. What is happening? Your n is 5, right? So what is 5 minus 1? You get 4, right? So when you do 0 less than 4, that's what is happening. So this value is 4. How many times this particular execution will happen? 0, 1, 2, 3. 4 times.
Yes, sir.
Yes, 4 times.
So
yes,
4 times this particular procedure will get executed, correct?
It should not be done more than 3 times, sir.
No, it should be. That's the point I'm telling you. If you do not execute it 4 times, you 4 to 0. This will never happen. Okay. You will reach from 0 to 4, but you will never come back from 4 to 0.
Okay.
That's the point I was telling you earlier also. This particular link from 4 to 0 will be missing if you execute it 1 less time.
Okay. Yes.
Then that matrix of 0, 0 will never become 1.
Okay.
You're getting?
Yes, sir. So this is where we got wrong also. I got this last answer incorrect because I was considering that there is 0 between 0 and 0. There is the value of this B matrix is 0.
See, because you thought it at human level, you did not follow what pseudocode is doing.
Okay.
Pseudocode is not stopping at 4. It is taking that extra step, and because of that, 5 is getting added after 20. I believe that's the answer for the previous iteration. I mean, 1 less iteration if you do, then the answer will come as 20, right? As you said.
Yes.
So that's the point. You are not following what pseudocode is doing. You're just following what naturally, which intuitively coming to your head, right?
Yes, I got it now.
Yeah, I mean, I understand, but natural, as you said, right? Nobody wants to know whether there is a path from 0 to 0 or not, but that's not the point here.
Okay.
In fact, in this case, I think you would want to know whether you have the path from 0 to 0. For example, if you're giving a list of stations, you would want to know whether you will be able to reach home after going to another station. No?
Yeah, I mean, if you take it, consider that way, right? You started, maybe you want to do a road trip, I mean, a train trip.
Yes, sir.
And you want to somehow you want to visit multiple stations and come back to your home. In that case,
so
you want to know there is such path or not.
But then we also have we can know that because there is also a edge from 4 to 0. Suppose we say that 0 0 is 0. Value of 0 0 is 0. But we know that there is a edge from 4 to 0. So we know that we can go from 0 to 4. At the same time, there is a edge from 4 to 0 also.
Yeah. So what is the meaning of, see, what is the meaning of that? When you say there is a edge from 4 to 0, what is the meaning of that?
There is a way to go from 4 to 0.
Correct?
Yes.
So as per one hop matrix, there is a way to go from 0 to 0 also. So if you cannot apply same a different logic for 4 to 0 path, you applied a different logic for all the paths from 0 to 1, 1 to 2, so on till 4. Only for this one last path, you cannot apply different logic. Are you getting my point?
Yes, sir. Yes, sir.
See, whenever you find a list, let's say you're initially 0 to 2 was 0, right? In the matrix. You found a path from 0 to 1, 1 to 2. And because of that, you made 0, 2 as 1, right? Correct? You should do that same thing when you find a path from 0 to 0 also. Just because your starting and ending station is same in this case, you cannot change your procedure for that odd case.
Yes, sir.
That's the point. Whatever your procedure you write for one hop has to be same, irrespective of what your starting station is and ending station is.
Yes, sir. Also, how is third option actually correct, sir? Which third option? Yes, sir. K in columns. No. K in rows. Sorry, the last one.
Last one. Okay.
K in rows. This one and the previous block, if you observe, B of R comma K and B of K comma C, where in first case K is taken as column and second case K is taken as row. But
it doesn't matter, right? It's just the way you are iterating over a matrix, either row wise or column wise, doesn't matter unless
we are having n cross n matrix here.
It's a square matrix, right?
Yes,
sir.
So it actually doesn't matter whether you go row wise or column wise. You will end up traversing entire matrix, right?
Yes, sir.
That's the point there.
No, if K in rows, if K is if K belongs to rows, then it should be like B of K comma R is equals to 1 and B of RC is equals to 1. Then it becomes B of KC is equals to 1.
No, I'll tell you what is happening. Okay.
Yes, sir.
Is it necessary to mention first row in the matrix whenever we try to access a particular value in the matrix? Is there mandatory to have row as the first entity?
Yes, sir.
No, sir.
No, right? There is no limit.
If we are doing a column operation, then not necessarily.
Right. See, what our actual original dictionary is. All the keys are there in first level as well as second level.
Yes, sir.
And if there is a train from first key to second key, then definitely there is a key train from that in the reverse direction as well.
Yes, sir.
So that's if you consider both these points together, there is no problem in accessing that other way around, instead of columns row or row instead of rows columns.
So, but
it is interchangeable, right?
In this case, we do not have a train from R to K and then K to R.
What is happening? Okay.
I don't think in this case we have a train that goes from station 1 to 2 and then 2 to 1.
That is always such a train, right? That's how train data set is.
But in this case, I don't think
No,
that
sir.
that is.
Sir, it's not. It will not happen always. I think what he's trying to say, it is correct.
Yes, sir.
Because we are not sure that it's a symmetric matrix.
Yes,
it is always symmetric matrix. If you remember, if you watch that lecture,
sir,
that
then
data set is
No,
explained, right?
sir. Sir, actually, according to this pseudocode, it's not mentioned like if we have an edge from 0 to 1, it is not necessary that we're having edge from 1 to 0.
So that's the point. Why do you have to explain that every time?
Sir,
See,
in
if
that
you
case,
if you consider original this direct matrix, right? If ij is 1, definitely ji will be equal to 1 as per original trained data set. Why do we have to explain that or explicitly mention that in each question? That's my point. Why do we have to tell that thing in every question? It is something which comes naturally. Whenever we talk about trained data set, you have to assume that is the case.
So then in that case, the fourth option will also be correct.
Okay, what is happening in fourth option?
In fourth option, it is checking K2R then K2C.
Yeah, so K2R and K2C is different, right?
K2R and K2C
If you're
doesn't
saying
show
that
hops there.
if you're saying then R2K is 1, then K2R should be 1. So in this case, we are checking the same thing.
Okay, hold on. So what you are saying, we are iterating over column K, and okay, before that, what we have R and C, rows and columns, R and C. Okay. Okay, so with this, there is a train from K to R, and then there is a train from K to C, right?
And then we are setting B R2C to 1. And this would work if we have symmetric data set. But we don't have a symmetric data set. That is why this is incorrect.
No, we have symmetric data set.
So no, if it was symmetric, then B K to R would be 1, and therefore B R to K would also be 1. So therefore, this option will be correct.
Yes, sir, exactly.
Okay.
Sir, sorry to disturb you, but actually I was having problem with the question. Can you go to the question also, sir?
Yeah, we'll do that.
Everybody has some discussion about. Seriously, I can't understand single thing here.
Sir, I cannot understand the pseudocode itself.
Okay, we'll do that. We'll do that.
Sir, can I say about these two options, sir?
Yeah, sorry.
I can say about. Can I say about these two options, sir? Where
okay, go ahead. Go ahead.
Sir, rows of B 0, 1, 2, 3 up to n minus 1. Columns of B 0, 1, 2, 3 up to n minus 1.
Correct.
So we are considering both options, sir.
Sorry, I did not get in what sense you said that.
Sir, here station R to station K is under consideration, sir.
Correct. This one you are talking, right?
Yes, sir.
Okay.
Both the options are satisfying. Station R to station K. Only difference is rows of B and columns of B. In line number 1 of the both options.
Correct.
Rows of B is 0, 1, 2, 3 up to n minus 1.
Correct.
And columns of B also 0, 1, 2, 3 up to n minus 1. That's why we are considering these two options are correct, sir.
No, the fourth one is not correct. It is K to R, not R to K.
It's discussed about fourth option. And he's saying about second and third.
So I was talking about the answers option.
Yeah. Okay. So that is fine. Option these two are correct. There is no doubt about it. The argument is, I mean, the discussion is happening on last option, the fourth option. This rows and columns is I mean, I got your point that it's just a number, right? It will give you what the K will go from simply 0 to n minus 1. Doesn't matter whether you use rows here or columns here. That's that point I got it. That's the yeah, okay. So that's the point, right? Even in other way around what you're saying, in this case also, I mean, K will go from 0 to n minus 1.
Sir, but here station K to station R is under consideration. But we want station R to station K.
Yes, sir.
Right.
So therefore, the fourth option is wrong.
Okay. So Archit, I mean, you are going back to the original point that they are not symmetric. That's why we cannot consider this option. That's the point you are making, right?
Yes, sir.
Okay. Okay. Ideally, if the way I see it, that we should consider that they are symmetric as per the data set is explained to us. But yeah, as you said, right? If we consider, then this option also becomes correct. If we assume that part. Okay.
So normally the train which is coming back is having a different number. So maybe two trains. There may be a way to go from A to B, but there may not be a way to go from B to A. That may be possible, sir.
Yes, sir.
It is possible that way.
Yeah, I mean that the possibility is there because in fact, the train number might change, but starting station and ending station will remain same, right? It's always the trains always come in pair. Always, not just our data set. If you even pick up the actual trains in India or any country, they always come in pair because somehow physically train has to go to other station to come back, right?
Yes, but they might follow some other path.
Path might be different, and which is actually there in the data set, but still starting and ending station will not change. Intermediate stations might change.
Yes, sir.
Right, that's the point. Here we are not considering intermediate stations, right?
So we might be considering.
Yeah, we might be. Yeah, because of one hop, we might be considering. Yeah, in that case, it may not become symmetric.
Yes, sir.
Yeah, the direct matrix, original direct matrix will be symmetric, but later on we might lose that symmetry. If they are following different paths while going and while coming back. Which is actually there. I mean, in one of the lecture also, professors find out that the distance of one train and the return train is different because they are taking some different path. I don't remember which lecture, but it's there in one of the lecture also. So in that sense, maybe the direct matrix is symmetric, but later on we might lose that symmetry.
Yes, sir. Yes, sir. Direct matrix should be symmetric. Yes, sir.
Yeah, it will be symmetric because starting and ending station will always remain same for that pairs of trains. But later on, because of different intermediate stations, we might lose that symmetry. Okay, fine. So let me go back to original question from where this whole discussion started.
Suppose just one case, sir.
Yeah.
Suppose there is a train which goes from A to B. There is another train which goes from B to C. And then there is a train which comes from C to A back.
Correct.
So there is no direct route from A to C, but there is a direct route from C to A. So direct matrix also may not be symmetric. Suppose there is a way to go from A to C via B. So there is no direct edge from A to C, but there is a direct edge from C to A.
No, if there is a direct edge from C to A, that means there has to be a direct train from A to C. That's how train data set is.
Okay.
That's what I was saying. See, with a difference of one number, that's how the trains are. If you have that 1, 2, 2, something 26, then 27 will also be there. That's how trains are. I mean, not the way we are designing. These are actual trains. Duronto trains. If you pick up the Duronto trains from India, you will see these same trains. So these are not some made up trains. These are actual trains running in India. Okay, but yeah, I mean, we don't have to go into those actual trains and all that for solving these questions. But yeah, maybe you should consider this part here onwards. That direct will be symmetric, but we might lose that later on, as we discussed just now. All right. So originally, Karthik, was it you who were saying you have, or Dev, right? Dev, you were talking about the question itself, right?
Yes, sir.
Yeah, sorry. Yeah, tell me which part of this question you did not understood.
Actually, sir, as I started the question, there was BR, then C, direct RC. From the hops part, I can't understand why the hop was there. And after that, I just guessed the answer and it was wrong. I chose the fourth option.
Okay.
And it was wrong completely.
Okay.
I can't get the entire pseudocode.
Okay, so the doubt is about the pseudocode, not these statements at the top. This part you understood, right?
Yes, sir. This part I understand. If there is an edge, I would come 0, 1. Sorry. will come one.
Okay.
Direct.
Okay. Fine. Okay. Somebody else also asked that some girl asked about that she was not able to understand pseudocode. May I know who that is?
I am.
Sukanya, right?
Yes.
Yeah. Okay. So maybe I'll go through this pseudocode once. So Dev and Sukanya, maybe just listen to that. Okay.
Okay, sir.
Okay. So what is happening is we started with what is n? N is the length of keys of direct. What is direct? Both of you have to answer these questions to me.
Direct comes out the train from one station to another station. The dictionary. Direct train.
Yeah, it's a dictionary, right? So keys. What will be the keys of direct?
Keys of direct will be number of trains.
All the stations.
All the stations. Sorry.
All the stations. So length will give you total number of
Can
stations.
you just summarize what is direct, sir? Can you please, sir?
Okay.
Explain?
So direct is it's a dictionary which tells you whether there is a direct train from station X to station Y or not. If it is there, then for that particular location in that matrix or in that dictionary, you will have one.
So direct means if I have to go from Mumbai to Bangalore, it's a direct train, no station in between.
Right.
Okay. Yes.
No, sorry. No station in between, as in you do not have to change the station. Of course, train will stop at some stations in between. Right? We are not. That's not the point here.
Okay. I got the route.
There is a train which starts from Mumbai and go to Bangalore.
Okay.
Right.
I don't have to just change the route also.
You don't have to change the train in order to reach.
Here.
Yeah, in order to reach from one city to other city, you do not have to change the train. Okay. That's what that direct is. If that is the case, then you will have one for that particular entry between those two cities.
Okay, sir.
Understood?
Sir,
yes, sir.
Yeah.
Sir, you have actually discussed previously that direct is a symmetric matrix.
Yes.
Sir, but actually I assumed a case where it's not. Like if you go from A to B and then B to C, take a train, the starting point is A and the ending point is C. Okay.
Yeah.
Then that train, I mean that physically that train will return from C to A.
Right.
It will not take the path from C to B, then B to A.
But then that is a train with one hop in between, right? A to C by hop, which is B in between. That means we are talking about two trains, not one train.
Okay.
And that's anyway not a direct path, right? I'm talking about direct when there are direct trains from some city X to Y.
Oh, sir, but direct is, I think, if we have, I mean, reach from city X to city Y via train, then it will be one for that entity.
Yeah, correct. For X and Y, it will be one. If something comes in between, we are not making one for those stations. Only for starting and ending station of a train are considered.
Oh, okay. Then for A to B, it will not be one, is it?
Yeah, correct.
Okay.
See, if you look at the pseudocode, right? What is happening? We are taking only the starting and ending of that particular tree.
Yes, sir.
Or even initially, if you see when the direct is, we started computing it. We are taking, see, for each train, there will be some 10-15 stations on the card, right?
Yes, sir.
We are not considering all the stations. We are considering only the first starting and ending station. That's all.
Okay.
So we are adding age between only those stations. There will be some, I mean, as somebody was pointing out, if you are going from, let's say, Bengaluru to Mumbai, right? We will may add age between only Bangalore and Mumbai. Not the stations in between where the train stops.
Okay.
Then it will become nightmare to process that information, right?
Okay.
Yeah. Okay. So coming back, Dev, is that part clear? Sukanya?
Yes.
Yes, sir.
Okay. So that is our direct train, and then from there we are taking length. That means N will be all the stations what we have. Okay, all the startings or ending points or some stations or some trains. I mean, every train will have some starting and ending point, and that's the collection. I mean, whatever that unique number is there, right? That's our n.
Okay.
Then we are creating a matrix of that particular size. It's a square matrix. So if there are such 100 stations, then our B will be 100 by 100 matrix.
Okay, sir.
I mean, ultimately it's a dictionary, but if you visualize it graphically in a tabular structure, it will be 100 by 100 matrix, right?
Okay.
Then we are iterating on that particular matrix. So it's a two-dimensional entity. So we are iterating using two loops, right?
Okay, sir.
And then this particular B, right? B is what?
B is the matrix, the mini matrix we are creating.
The B is the matrix which we created, and the create matrix always gives a matrix with all zeros in it.
Yes, sir.
So initially B of anything inside it, the B matrix will have all zeros. 100
so
by
this
100
I
into
can't
100.
understand.
See, the create matrix function is explained in one of the lectures. Okay.
Yes, sir. It has been explained.
It is explained in one of the lectures, and as per the explanation for this particular function is, or this particular procedure is, it gives you a matrix of size n by n, or whatever values you pass here, and all values in that matrix will be 0. Okay. Sukanya?
Yes, sir.
So what is B? B is a matrix of size n by n, and all the values in that matrix are 0. All zeros are there.
Okay.
That's what you have to assume after line number 2.
Okay.
Now we have to insert some values into that matrix as per this direct train. That's what we are. That's why we are running these lines of code. Okay.
And
so
we'll give the number of stations which have direct connectivity.
Yes, correct.
Number.
Okay. Length, right? Length is always a number, right?
Okay.
Yeah. So what is happening? We are picking every pair of stations. R is what? It runs from 0 to n minus 1. And C also runs from 0 to minus 1. One runs from rows and other one runs from columns, but all will be running from 0 to n minus
1. Right.
So we are picking every pair of such entries, right? RC, maybe initially 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on, right? For each such entry, we will find its equivalent entry in this direct dictionary.
Yes, sir.
And if whatever value you have originally there, you will simply copy it here.
Okay.
So how will it look like, sir, with like with example? Like I couldn't form this structure.
Okay.
So one question here.
Yeah.
Can't we just write B equal to direct here instead of this for each R in rows, for each C in columns? Can't we just directly write B equal to direct?
B is equal to direct, huh?
Yeah,
I mean, actually, it depends on which programming language you are using. Okay, see, the point is, as per this, direct is, I mean, internally direct and B both are dictionaries. That part is correct. So you can copy one dictionary as it is from, original dictionary to second dictionary. That's possible. But if you do it in Python, there are some drawbacks of doing that. As we call it, side effects. Some side effects are there.
Okay.
So I'll just quickly tell you, you understand, it's fine. Otherwise you ignore it, or else just follow this and next term you will know why. If you do that, if you change B, right, direct will also get changed.
Okay.
That's the problem in Python. Some languages do have that problem, and because of that, it's better not to do such just one line equal to them. Okay, so whenever you start learning Python, focus on something called as shallow copy and deep copy. Remember these two terms, and when you study these two terms, you will understand it even more clearly. Okay? Yeah, just remember this part, shallow copy and deep copy. Okay, so for now, so Sukanya will just explain you this with some example. Okay, consider this particular entity. Sorry.
Okay. So you have this direct dictionary. Okay. I'll take some stations and whether there are trains or not. Some small values I will take, and then we will take it forward from there. Okay. So for station A, okay, direct is a dictionary with true and false, right? Yeah, with that train numbers also. Okay. So for A and B, there is train number 100, and that is true. Okay, there is another train which is true. Then for that same A, there is, let's say, station C, and for that station again there are, let's say, train number 300, which is true. Let's say there's just one train for this, and then this is B. This is B got ended here. Okay, so now we just have 3 stations. Let's assume A, B, C. Okay, and after that, so for
just one thing, sir. A is the key in this, no? A
yes, A is the key, and against that value is this dictionary.
Okay.
What does this mean? There is a way to go from A to B, either using train 100 or train number 200.
Okay.
Okay. Okay.
Okay. There is a way to go from A to C using train number 300.
Okay.
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 Now, similarly, we can do it for station B. I mean, for station B also, there should be some way, right? Now, for from B to, now we have to go to, let's say, A.
Yes.
Okay. And for this, let's say this is okay, there is a path from A to B, so there has to be a path from B to A, and that B to A path will be just a copy of this with +1. That's how ideally it will be. So this will be 101 and this will be 201. Okay. Because it will be, see, A to B we can go with 100 and 200, so B to A we can go with 101 and 201.
Okay.
That's how it goes. Similarly, for C, let's say. No, for B, we have to add C also. So this is okay. That is A. Okay, over here. For C, right?
I
think I made a mistake here. That's why I got confused. For B, for A, this is one key and this is second key. No, it's correct. Okay. For C also, earlier A to C path was there with 300. So now we are doing for B to C. Let's say B to C, it doesn't exist. So it's just empty. There is no way to go from B to C using direct train.
Okay.
Okay. And then for C, again, we should have 2 stations, A, which is a dictionary, and station B, which is a dictionary. Okay. So now we are going from C to A. That means we have to check what is A to C. A to C 300 is there, which is true, right? So in this case, it will be 301, which is true.
Yes.
And earlier, if you remember, now we are checking from C to B. But if you remember, from B to C, it was empty. That means there is no direct train. So that means there is no direct train from C to B.
Okay.
So this is our, let's assume there are only 3 stations and 6 trains. 100, 200, 300, 101, 201, 301. And with this, we want to construct that B matrix, right? That B matrix.
Yes, yes.
So now that B matrix will have what all rows will be there? A, B, and C. Okay.
Yes.
And what all columns will be there? Again, same. A, B, and C. Right?
Yes.
Now, this is a direct matrix, right? So there is no direct train between A and E.
No.
Then there is no train between B and B.
No.
There is no train.
Yes.
Okay. Presentable. Okay. There is no train between A and A, B and B, and C and C. Obviously, right?
Right.
Now, A to B, there is a train. A to B, there are two trains, but that's not what you're interested. We just want to know whether there is a train or not, right?
Yes, yes.
So A
So
to
one.
B, there, yeah. So
One.
if there is a train, we just simply make it one.
Yeah.
Then A to C. A to C also there is a train, so we make this also one.
One. Yeah.
Then we start with, let's say, B. B to A.
One.
There is a train. B to A. B to C.
Zero.
It's empty, right? There is no train, so
Yes.
it remains
Zero.
zero. It was already zero. By the way, everything was zero when we initially started it.
Oh, yeah, right.
I told you, right? When we call that create matrix function, everything is zero initially. Later on, we make it one whenever we find train.
Yes, yes.
So A to C, we did not find anything.
Hmm.
Sorry, B to C. B to C, there is nothing.
Yes.
Right now, we are checking for C. C to A. Yes, C to A is
One.
there. So old value was 0. We replaced it with 1.
One. Yeah.
Understood?
Yes, yes.
And then C to B, it doesn't exist.
Yeah, right.
So there are 3 stations, but only 2 stations are directly connected. A to B and A to C are connected,
Hmm.
but B and C are not connected directly. Right?
Yes.
So this is your direct train, direct B matrix. Are you getting this point?
Yeah.
Understanding?
Yeah.
Okay. Just give me a second. Hold on.
Yep.
Yeah. Okay. So this much part, have you understood?
Yes.
Yeah. So that is what is happening over here. Is this clear?
Yeah.
Okay. Now, shall we go back to the pseudocode?
Yep.
Okay. So that is what I explained till this particular line.
Right.
Right?
Right.
Okay. Then we declared something. I mean, now what we are supposed to do? Earlier, we just found trains which are directly connected. Right? Now we also want to know, is there a way to reach from one station to other station by going through some other station? If, let's say, from point A to point B, there is no direct train, but there is a possibility to go from A to B via some different path, right?
Yeah.
So that different path, the different station is the place where we will change this train, right? For example, you want to go from Bangalore to Delhi.
Yeah.
For assume there is no direct train from Bangalore to Delhi. Maybe you will take one train from Bangalore to Mumbai, and from Mumbai you take second train from Mumbai to Delhi.
Yeah.
So that means you are taking one hop in between. Which is your hop in this case? Mumbai becomes your hop in the journey from Bangalore to Delhi.
Yes.
Got it?
Yeah.
That is what now we are trying to calculate, compute using this particular procedure. That is there, I mean, direct path, we already understood by this particular thing that it doesn't exist. What if there is a path via some hop in between? If there is, then we should make that also entity as 1 in that particular matrix.
Okay.
As we said, right? There is no direct path from B to C.
Yes.
But A to B is there, A to C is there.
Yes.
And also B to A and C to A.
Yes.
So you can go from B to C via A, right?
Yes.
You can take a train from B to A, change a train, and then take another train from A to C, and you will reach to C.
Yes.
From B, right?
Yes.
For that to happen, we are computing this.
Okay. Sir, one more thing.
Yeah.
So like here in line 5, BRC equal to direct RC. That means like, should we write any kind of value there?
No, see, direct RC already has a value, right?
1.
Yeah, no, I mean, yeah, in this case once, I mean, don't go by that exact dictionary what I was explaining. I will just explain you with that example. Yeah, see what is R and C are two stations. Let's, whatever I was explaining. If there is a train from R and C, that means direct of RC will be 1 as per what is given over here.
Yeah. Okay.
It will be 1, right?
Okay.
And if that is the case, you make BRC also 1.
Okay.
Okay. So ultimately your this B matrix will hold all the direct trains.
Okay, got it.
Got it. And then using this procedure, we are adding those hops. I mean, may mean if there is no direct path, but there is a way to go with some hops in between, maybe 1 hop, maybe 2 hop, 3 hop, and so on.
Okay.
And that is something we have to keep computing again and again. If 1 hop we are not finding, then we should look for 2 hops. If 2 hop also we are not finding, we should look for 3 hops.
Okay.
And how long we will do it? For all the possible stations, except the starting and ending point, right? That's why we are doing it from 0 to n-1. Those many number of times we will call this procedure. And this procedure, what is happening in this procedure? It is let's take this particular example. I mean, just you're saying that, I mean, these 2 loops are executing. Inside that, let's say this code is executing. So what is happening? We are trying to find path from R and C. Assuming R and C are not connected directly. Then we are trying to find such a K so that there is a path from R to K and there is a path from K to C. That means at station K, you can change the train, and that's how you can reach from R to C.
Yes.
Like in that sense, previous example, your R is Bengaluru, C is Delhi. So you are changing station K at Mumbai.
Yeah.
Right.
Okay.
So this direct train is there. This direct train is there. And because of that, now you can say there is a train or there is a way to go from R to C, which is Bangalore to Delhi.
Okay.
With 1 hop in this case.
Okay.
So you can keep doing this n number of times. You might not find path from, let's say, you can split this, right? Earlier we were talking about Bangalore to Delhi, and then we split that part into in between at Mumbai. For example, you may not even find direct path between Bangalore and Mumbai. Then maybe you can take one stop in between also. Right? You can break down that particular journey again with some hop in between. Maybe somewhere in Karnataka, maybe I was talking about the Belgaum. Maybe you can try that as a hop.
Okay.
Same thing you can do on the other path towards north also, from Mumbai to Delhi. Again, if you are not able to find that path directly, maybe you can find path from maybe Mumbai to Bhopal and from Bhopal to Delhi. So you can keep adding these hops in between. Earlier, there was only 1 hop. Now we added 3 hops. One was Mumbai, then we added 1 hop on the north side, 1 on the southern side of Mumbai, right?
Yes.
Like that, you can keep adding hops.
Yeah.
That is what this procedure is doing.
So, sir, like here, line number 14, 1 more hop B, and for each R in rows B, that means this B is matrix of direct one.
Yeah, B is that original matrix.
Okay.
That we are passing as a parameter, right? Over here, we are passing that B. And then as per any of these codes, your B will be updated with some 1 will be allotted at some place, right? B will be updated. And when the B gets updated, after that updated B, we are returning back. That will update the original B over here.
But sir, how to check this line number 9, whether it's true or false?
Yeah, because your hops will have some integer value. You are checking whether it's less than n or n-1 or not. If it is less than n-1, you will execute these 2 lines, because hops is also getting incremented, right? At some point, your hops value will not satisfy this particular condition, because it will start from 0 to 1 to 3, 4, 5. At some point, it will not satisfy this condition in -1.
And here
That's
n is
where you
our
stop.
length.
Sorry?
N is here is the length. No?
No, n is the total number of stations. You remember this? N is the
Yes,
total
yes.
number of stations.
Length. Okay, okay.
Length of that list,
Yeah.
which is total number of stations.
Okay, okay, okay. Okay, got it now.
Got it?
Mm-hmm.
Okay.
Sir?
Yeah.
Sir, I have a doubt. Like, I have a claim that it is not necessary that direct dictionary, the dictionary direct is a symmetry dictionary. Like, I have assumed a case.
Okay,
also.
okay. Hold on.
Can you?
Let
Yes,
me
sir.
cover this. I will come back to you. Okay?
Yes, sir. Yes, sir. Okay.
Yeah, okay. So, Sukanya, is this part pseudocode or in the Dev? Is it clear?
Yes, yes.
Yes, sir, it is more than clear. When you call the bus, just one thing, sir, when we call the procedure B equals to, in the line 10, B equals to one more hop B. So it comes down to procedure one more hop B, and it returns the value of B.
Correct.
So when the value of B is returned, so the value which we had of B, which value is changed to it? Before that, B was a matrix, na?
Yeah, it is still matrix. We are not changing that. It is still matrix. Only some values inside that matrix will be changed.
Okay, and then
See, this RC will become 1, right? As we said earlier, Bengaluru to Delhi was 0.
Yes, sir.
Now we found that K Mumbai in between.
Yes, sir, I
Because
got
of
that.
But this will become 1, which was
sir,
earlier 0.
What is the difference between K in columns and K in rows?
See, rows and columns doesn't matter. You don't have to worry too much about it because our matrix is symmetric. So rows of B and columns of B, either of these statements will give you numbers from 0 to n minus 1.
Sir, so then the last option will also be correct.
No, the last option, the problem
K2.
was...
Oh, okay, sir. R to yes, sir. We are checking K to R. No. We have to check from R to K, then K to C.
See, you somehow want to find path from
sir.
R to C.
R
So
to
there has
C.
to be some K in between these two.
Okay. Yes, sir. Now I got that.
Understood? Sir, out of these 3 options, 4 options which are given, out of these 3 options which are correct, the first option is the one which will be executed fastest, right? This one will be executed fastest as compared to the second and third option. Because
yes, sir. Because exit loop is there.
Yes, sir.
This one will be executed fastest. The second and third option, it will take a lot of time for the computer to execute.
Okay, what is happening here? RC is 1, we are simply executing, and or else we are we are trying to find it.
So compilation time will be less.
Yeah.
Yes, sir. It is mentioned in the solution also.
Yeah, it will be faster because as soon as we find it, we're terminating this loop, right? I mean, this loop, the innermost for each.
Yes.
So yeah, it will be faster, definitely.
And sir, one more thing, in this, in week 10, this is graded assignment 9. In week 10, in one of the lectures in which Dr. Madhavan is explaining this hops and all that, he's saying that if there are n stations, there can be maximum n minus 1 edges between these stations.
Correct.
And if there are n minus 1 edges, there will be maximum n minus 2 hops. N minus 2 hops, right?
Correct.
So, Dr. Madhavan has not considered the case where a person is starting from station 0 and coming back to station 0. In that case, he has to cross n edges to come back to station 0.
Yes, correct. In order to form that cycle, you'll have to add another hop and another edge.
So you'll have to go through n edges and n minus 1 hops to come back to the same station.
Correct.
Okay.
You take simple small example of 3-4 nodes and draw it in a graph. It will clear. It will make it more sense, right? It will be easier to imagine that. Yes. Okay. So coming back to Bishwajit, go ahead. You were saying something.
Okay, sir. Suppose we have 4 nodes. I mean 4 stations named A, B, C, and D. Okay. Then from A to C, there is a direct train from A to C. And it stops on B and C. Okay. A to D. Sorry, from A to D, there is a
train is from A to D.
Yes, sir.
Okay.
And in between, it stops on B and C.
That also. Hold on.
Yes. Can you use your notepad? Yes.
Yeah, that's what I'm saying. Yeah, there is a train from A to D. Next.
Yes, sir. And in between it stops on B and C.
Okay, in between it stops at B and C. Fine.
Yes, sir. And it will return by taking another path from D to A. Okay.
Okay. Your D to A, but in between, yeah, some path is different. Can you tell me?
No, sir. It's direct. I mean,
okay, nothing is there in between. Okay,
yes,
no station
yes,
in between. Fine.
Yes, sir. Because we are having maximum of 1, 2, 3, 4 trains.
Yeah, fine. Got it.
Yes,
no
sir.
Station in between. Okay.
Yes,
next.
Sir. According to you, can you please draw the matrix that direct?
Okay, so for this, in that particular matrix, there will be only two ones, AD and DA. That's all.
Okay.
All will be 0.
Okay. So if we just consider direct matrix like this, then later on, while finding that reachability matrix, that B matrix in the pseudocode, there must be an edge from A to B or like A to C.
Yeah, there will be a edge from A to B and A to C, you are saying, right? No, there won't be.
Sir.
There won't be. We are considering only the starting stations and ending stations. B and C are intermediate stations, not starting or ending stations.
No, sir. I'm asking about that matrix B.
Okay.
In matrix B.
Right, but matrix B also comes from where? From direct dictionary only, right? So originally your AB and AC will be 0.
Okay.
Are you getting my point?
Yes, sir.
Originally, what your matrix will look like? Your matrix will have only 2 ones in it. I mean, value 1 will be there only at 2 locations, AD and DA.
Okay.
Let me take that. So this is 0, this is 0, AD is 1, this is 0, 0. So this is 1. This is how your original matrix will look like.
Yes.
How will you find hop from, I mean, if you say A to B, right? It's already 0.
Yes, it is already 0, but according to question, we must have an edge from A to B.
Why?
Because we are having a train from A to B.
No, we do not have train from A to B. We have train from A to D, which stops at B. The train is not from A to B. The train is from A to D, which stops at B in between. B is neither starting point nor ending point. It's an intermediate station, which we are not considering as per what that direct matrix is. That's why I'm saying we are considering only the starting and ending point of a particular station, of a particular train. I have to go back. Let me just show you what I'm talking about. So for example, if we take this example of train number 12281, right?
Yes.
We are considering only Bhubaneswar and New Delhi. So we will add an age between Bhubaneswar and New Delhi. That's all. We will not consider these stations in between.
So we are assuming that a train starts from Bhubaneswar and ends at New Delhi without stopping in between.
We are not assuming that, but we are not considering where it stops in between. Okay. That information is there, but as per what pseudocode we have, we are not considering that information. That's why I said if we start doing that, our pseudocode, I mean the processing will be a nightmare. That's why we are just storing. If you look at that pseudocode from the slides, right? We are just we have created two special keys over there: start and end.
Yes.
We do not have intermediate anywhere over there. Just start and end. Forget about what comes in between. That's not. We're not considering it.
So in this, sir, direct matrix, if we want to incorporate this train 12281, what we can do is we can consider the route from Bhubaneswar to Balasore as 1, Balasore to Adra as 1, Adra to Varanasi as
not just that, even Bhubaneswar to Adra.
Okay.
All those nested things will come. That's why I said it will be a nightmare for single train. Consider all trains.
Sir, it will be a very long, graph like.
No. I mean, graph is. I mean, in fact, in that case, if you assume everything will be connected to every other station.
Yes.
But some or other, I mean, through some or the other hop, right? Ultimately, everything will be connected.
So every value will be 1, right?
Yeah, the entire matrix will become 1. Then it doesn't make any sense computing something like that. You're getting my point?
Yes, so suppose, sir, we consider Bhubaneswar to Balasore as 1 and Balasore to Adra as 1. Then Bhubaneswar to Adra will be 1 hop, na, sir?
No, why? Why you will? That's the point, right? Then there is this argument whether to consider Balasore as a hop or not.
Okay.
Because it's still the same train, right? You are not changing the train. You are not taking hop. You are same. You are on same train.
We are considering that these are two different trains. Bhubaneswar to Balasore is one train, and Balasore to Adra is.
But that's not the case, right? This is the same train, so it's not a hop technically.
Oh yes.
It doesn't make any sense.
That is why. That's exactly the precise reason we are ignoring these stations in between.
Okay, sir, but if you just clarify it in the question, it would be better.
Okay, tell me which question? That same question?
Yes, sir, same question. Like we should consider for the starting station and ending station.
Okay, you are saying that we should explain as part of the lecture.
No.
Sorry, as part of the question you are saying.
Yes, sir.
See, that is. I mean, it's precise. I mean, it may not have mentioned in these exact words, but it's there. Where is that question? Okay, what it says? There is an edge from station I to J if and only if there is a direct train from I to J. When we say there is a direct train from I to J, that means we are considering I, J as starting and ending points. And this particular direct matrix, right? It's precisely mentioned in the lecture also, right? That same thing we are using everywhere.
Okay.
There must be.
See, in that case, we have to explain this create matrix also. We'll have to explain keys also. We'll have to explain length also. That's not possible, right? These things which are explained during the course has to be assumed in that way, right?
Yes, sir. Got that.
Yeah, that's the point. We can't continue to explain everything in every single question.
Okay, sir. I have one more doubt in practice assignment.
Okay, hold on. I mean, we had long discussion. Just one more person is there. Maybe take his question and come back to you. Okay.
Okay.
Yeah, Karthik, do you have anything different, or your doubt is already cleared and your hand is you raised this from previous time? Karthik C. I think there are two Kartiks. Karthik C. Okay, fine. I'll come back to you. Maybe if you're talking, you are on a mute. But yeah, Aditya, you raised your hand, you took it down. You have a doubt? Aditya?
Actually, my doubt was in the same question. So now it's clear.
Okay, great. Okay, then maybe Vishwajit, you are alone. Go ahead.
Yes, sir. Sir, practice assignment 9, first question.
Okay.
Yes, sir. Sir, here I think we are having an edge from I to J where I is equal to J. But we should not consider for that. then in the
Range from
answer
I
it
to
must be
J,
written.
if okay, we are not okay, as per the what is the sorry, hold on. Yeah, this is nightmare. It looks okay. Do you remember which option is correct? Option 1, 2, 3, 4.
It's 1, sir.
1. Okay, the first one is
Yes.
correct. Okay. Okay, so you are saying I and J, we are not checking that. And is it required to check that in this question?
Yes, sir,
Marx is
because
read physics. Okay, let me go through the statement once.
yes, sure.
Okay, so the difference between physics marks is at the most 5, right? Maximum 5 is allowed, right? And if
Yes.
that's
Yes.
the case, so we are adding age between them. I mean, we'll make that entry as 1.
1.
Okay, so as per the given definition, same student, if we compare with, he is compared with himself or her is compared, I mean, the same student is compared with that same student. Ideally, it satisfies this condition, right?
Yes. Yes.
I mean,
sir.
whatever condition is mathematically, it is satisfying. Whether to do that or not, that's a different story. But as per the statement, it satisfies, right? Because difference
Yes,
will be
sir.
0.
Yes.
Is there any harm in doing that? I mean, I understand we can avoid that. I totally understand by adding
if you could just
I not
add,
equal to J, just
yes,
by adding
yes.
one if here I not equal to J, we can avoid that. But is there any problem in doing that in this particular question? Are
No,
we getting
no,
some
it's-
wrong answer or something? No, right?
No, sir. No.
No, okay. Yeah, then sometimes if that's the case, we might ignore it. I mean, it's not something, I mean, how should I put it? Yes, if we add it, it will be better. It will be even better code, but the current code is not wrong. Right?
Yes.
Yeah,
Yes.
sometimes it makes a difference. That case we have to add it. But in this case, it's okay maybe. I mean, no harm in doing it, right?
So then for every student, it will be one like
Yeah, so that principal diagonal of that particular matrix will be 1. All will be
Sir,
1.
but in question, it is can you scroll up a little
Yeah.
bit? Yes. It is given that there is an edge between 2 nodes. What
Yeah.
about 2 nodes? 2 means 2 different nodes.
Yeah, in this case, 2 nodes are same nodes, right?
2 nodes can be same.
Yeah, I mean, as per the code, they can be same, right? Because we are not checking that specific condition. Over here, we are not checking whether I and J are equal or not. So there is a possibility that they will be equal. And that
Okay,
age
but
will be added.
how can there be an edge between the same node?
Yeah, it's called self loop. I mean, in graph theory, it is allowed, and that it's a special edge called self loop.
Okay, okay.
Yeah, so it exists. It doesn't have much of an application. It doesn't serve any purpose, I have to be safe, but it exists.
Okay, okay.
Yeah. So
Okay, so then
whatever you are saying will make this code even better. I totally agree. Ideally, we should. I mean, we should add that. But even though we do not add, it doesn't make any. I mean, it doesn't create any problem as such, right?
Okay.
Yeah, that's the thing. Rest you understood the question, right? Only this
yeah,
part
yeah.
was the confusion.
Yes, sir, yes. Yes.
Okay, okay, okay. You should be careful about it if it creates some problem.
Okay.
Otherwise, it's either is fine.
Okay, sir.
Yeah.
Okay, thank you.
Yeah, thanks. Okay, so is there anyone who has doubt? I mean, I do not see any hands raised. Earlier there were many.
Yeah. So
Yeah.
the 14 questions, sir.
Okay, yeah. So you went through the solution?
Sir, I went through that. I said now, sir, since this 14th and 15th, I can't install the pseudocode and what the question is asking, sir. If you just tell me what it's asking, then I can come to an answer only. I can't understand.
15, 16 is done, right? Now you got that.
Yes, sir. 15, 16 is done. So 16 in which sum is done on the which means what can I say? The direct train is the 0 to 1 is train, 1 to 2 is train. So we will get 5 for that.
See what is happening. Sum of R and C, sum is equal to B. See, B of RC will be 1 for various nodes as per this graph, right? So each one of those you have to count for every combination of R and C.
Okay, I mean just as 0 to 1 there is 1. So yes, sum will be 1. Then for 0 to 2.
So 0 to 2, tell me what will happen for 0 to 2?
It will also be 1, sir, because 0 we will take the case of K. Just
okay.
1 should be a K.
Yeah. If we consider K as 1, it will become 1. Right. Then
so 3 also 0 to 1. No. For 3 there will be difficulty.
Why?
Also, we can go through same procedure, no? 1, then 2.
One more hop. You can
okay.
n number of times, right? N minus 1 number of times.
So basically for every 5 there will be 5 sums. So there will be 25 coming. Right. I got that. Okay.
I mean, you don't have to keep doing 1, 2, 3, 4.
Yes,
to
sir,
see the pattern and do that 5 by 5
yes,
right? Yeah.
Sir, in this picture, can you scroll down? In this picture, can you tell that what is the number of total number of trains traveling in between these nodes? Will it be 1, 2, 3, 4, 5?
2 to 4. Yes, there are 5 trains.
Okay. That's it. Okay.
Yeah. The number of edges is equal to number of trains.
Excuse me.
5 different trains. Okay.
Yes, 5 different trains. Right.
Yes.
Yeah. Yes, Lakshmi.
Sir,
is it related to this?
Yes, sir.
Okay. Sorry, Dev. I will come back to. I mean, it just started, so yeah.
Just 1 point, sir.
Yeah, Lakshmi. Yeah.
Sir, here if it is from 0 to 0, it is 0.
0 to 0, it is 0.
It's not
yes.
connected. Principal diagonal.
Yes.
It's 0 to 1, it's 1, sir.
Yeah.
I'm just telling the elements of matrix.
Yeah.
0 to 2, we can take it as 1.
Right.
0 to 3, 1.
Right.
0 to 4, 1.
Right. So with that, later on 0 to 0 will also become 1.
Oh, through 4. That's where I got the doubt, sir. That's why I got only 4 ones in the first row.
No, late. I mean, initially it will be 0, as you said.
And it will be updated as 1. Yeah.
At some point it will get updated.
Got it, sir. Thank you.
Yeah.
Thank you.
Okay. Thanks. Yes, Dev. Okay. So now I think 16 is done. Now can you go back to 14?
Yes, sir. You don't have to solve the whole question. Just make me, just give me insights of what is asking
about this part, right? The statement.
Yes, sir. The pseudocode. Yes, sir. The pseudocode part, because I can't understand the correct answer also, because there was just 2 above. Actually, I chose the answer. I will tell you, sir, what I chose. I chose option number.
I mean, you chose it randomly or with some cautiously you decided you chose that particular option?
Actually, I was right.
You randomly selected something, right?
Yes, sir. But
then doesn't matter which one you selected.
I chose the
there wasn't any logic behind it. So anyways, fine. Leave that. Okay. Okay. Hold on. Let me read the question first. It's okay. Have you understood the question part? Or else parallelly I can explain you that also. Have you understood what these 5 lines of text is saying?
I got the summary that it is asking for the ancestor, means the message which is received by J, who was the is ancestor. We have to check who has sent it the message. Basically, I got that insight. If J has received a message, so I has sent it to who have sent the message to it.
Right.
I got that much insight.
Okay. Fine. Just give me a minute. Okay. Let me just go through the whole thing before start explaining. Okay.
Okay, sir.
Okay. There is some previous question. Okay. This is that messaging thing. Okay, this is same thing what we discussed in last solve with the session.
Yes, sir. Exactly.
Okay.
I still got it wrong. Actually, I was thinking the right option. Right.
Okay. 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 This is some procedure which we are okay. Okay, attendees I and J other than the host as input. So we will never give I and J. I mean, value of IJ will never be the host, right? It will be someone after that. That's something you have to assume. IJ are not equal and returns true if I is the ancestor of J. Okay, that means J receives message from I, then
Yes.
only will return true.
Okay.
So that means what? There has to be a H from I to J.
Okay.
Then
Yes.
only will return true.
Yes, sir.
Correct. So as per this, right? Now 0 is the ancestor of 1. How you know that? Because there is a H from 0 to 1. 1 received message from 0.
Yes, sir.
So IJ, in that case, yes, it should return true.
Okay.
Or
Okay.
at the same time, what about 0, 2?
0, 2. 0, 2 are also ancestors, sir. Because
Ancestor, right? May not be directly, but maybe a super ancestor, right?
Because 1 got 2 got message for 1, 1 basically got
So
it from
yeah,
0.
so 1 is ancestor of 2 and then 0 is ancestor of 1, and with that transitivity rule, 0 also becomes ancestor of 2, right?
Yes, yes.
So with this, you understood this. Till this part is clear with this example, right?
Yes, sir. This is
okay. Now this procedure A is that particular matrix which holds the this particular graph structure in a matrix form.
Actually, I will tell you specifically, sir, what I didn't understand. K
Yeah.
in the pseudocode also, the K was at the end. K was turning to C, and there was flag. There was flag which was turning to be true, which was turned into false in between the loop. So I was not understanding why it was turned false. Then at the end, it was selected to be true, and K was equals to C. That these 2 points I was unable to understand.
Okay. Okay. So, I mean, it is just a different way or different logic of iterating over that particular matrix. I mean, okay, fine. So which one is correct answer? So that I will explain you with that, feeding that code in between. Do you know which one is correct out of these?
Last one.
Last one.
Last one.
Last one. This one is correct. Okay. I have to scroll multiple times, but okay, fine. So what is happening? You start with while, which is initially true.
Okay, sir.
That means essentially, ideally, at this point, while becomes an infinite loop.
Yes, sir.
It will become false at some point, of course, but at this point, it is an infinite loop, right?
Yes, sir.
Then we are immediately making it false.
Okay.
Then till here, nothing much calculation is happening. It just see flag decides whether to stop or not. Beyond that, flag has no importance whatsoever the way I see it as of now. Okay. Maybe it might change after this code, but yeah. Then we are iterating over columns. That means nothing but numbers from 0 to n-1, right?
Okay.
All the nodes of the graph, right? And while doing that, yeah.
So all the nodes of the graph.
Yeah. So C will go from 0 to n-1.
C will go from n. So its sister is Aij. A is here a matrix that is okay. It's already computed.
Correct. So matrix, columns of matrix, that will be some. Ultimately it's a list, right? That's what columns of A returns. It returns a list from 0 to n-1.
Yes, sir. Yes, sir.
So C will go from 0 to n-1. Every iteration, these values C will hold, right?
Okay. Okay, sir.
Now, apart from that, there is nothing else is there in the code. Outside, we are returning false.
Okay.
If no return statement comes in between, in this highlighted code, we return false. No returns gets executed here. Then we return false, right? Is that part clear, right?
Yes, so that part is clear. But sir, at the start, why K is equals to I?
K is equals to I. Where K is equals to I?
In the question only, sir. K equals to I.
Okay, yeah. Originally, K is, we have initialized K is equal to I. So that means K is some, we have created a copy of I. I is what?
the starting point which we are supposed to check.
Okay.
So we copied that into K. Why that we'll see, I mean, even I don't know. When we see the rest of the code, we'll know.
Okay.
But right now K is identical to I, which is supposed to be the starting point.
Okay.
Right? The person which we are checking whether he or she is ancestor or not, right?
Okay.
That's same now. I and K are same now. Okay.
Okay.
Now when we look at this code, we are checking KC is equal to 1. That means, okay, when KA of KC equal to 1, when this will be true?
When K is an ancestor of C.
Right. When K, there is a, I mean, K has sent, there is a direct edge between K and C.
Yes,
now
sir.
we know what is K. K is nothing but I only.
Yes, sir. Yes, sir.
So that means ultimately what we are checking, there is an edge between I to C or not.
Yes, sir.
If that is the case, if that is the case, then we are checking C to J. That means we checked from I to C, C to J.
Means we are checking I to J only.
That means, for example, as per this, let's assume 0 is your I and 2 is your J.
Okay.
Then this is your C. That's what you are checking, whether this C you are trying to find.
Okay.
I to C, C to J.
Yes, sir.
If that is the case, you return true.
Okay.
That means you found your hop in between. From I to J, you found your hop C. And if you found that, you return true.
Okay.
Okay.
Yes, sir, but we have to check is an ancestor. If there is only one, that you give me example 0 to 2 is there. But if there is 0 to 1, we have to check between 0 and 1 then.
That's what. So if 0 into 1 itself, you want to check, right?
Yes, sir.
Okay. If you are checking between 0 and 1, then your your I and J is 1, 1, right? Sorry, 0 and 1. I is 0 and J is 1.
Yes, sir.
Then you see, in that case, what happens? Your K is 0,
yes,
and you're trying to find some C, right?
Yes, sir.
At some point, this C will also become 0, right?
How, sir?
Yeah, we are iterating over. This is C, right? C will always go from 0 to n-1, no matter what.
Okay.
It will always go from 0 to 1, right?
Okay, sir.
Right. So what is happening is, so whatever you are saying, 0 and 1, it's anywhere direct edge, right?
Yes, sir.
Okay. So, excuse. Yeah. So when C becomes either I or J, okay, either of those two.
Okay, sir.
Okay. For example, your C becomes J. J as in your, in this case, 1. At some point, your C will become 1. C is running from 0 to n-1.
Yes, sir.
Right? It will become 1 at some point, right?
Yes, sir. Yes, sir.
So your C becomes 1. So you are checking KC. KC is 1 now, as per the graph.
Sorry, 0, 1 is 1.
0 is 1 is 1. And C is equal to J.
1 equals to 1. Yes, sir.
So you return true.
Okay. Yes, sir, exactly the thing I'm asking. Na, if we are the previous example you gave, when you are checking 0 to 2, so if I say K equals to 0 and C is 1 this time, so 0 to 1 is equals to 1. And then we check C which is now 1, and 1 is J, we are checking 2. The 1 is not equals to 2.
It's not equal to true. That point, okay, that point it will not change. It will not. But then okay, hold on. Then your K becomes C, right? You are updating K also.
K will become C and C will become 2. Okay.
Your C will keep changing, and accordingly you are changing the K also.
Okay, we are just previous. Okay.
You're step by step checking all the possibilities, right? One after the other.
Okay.
Understood. That's why I said in exam you may not have time, but right now try to execute this maybe using this small example.
I got that.
Okay.
Completely got that.
Yeah.
Okay. Sir, just a small query in activity question 9.3, question number 3. There was a question.
Hold on. Let me see what that question is.
Just a small question. I will tell you.
Okay. Activity 9.3, right?
9.3, question number 3.
Okay.
Yes, sir. How many edges? The question number 3 was this. How many edges of a clique of n vertices will have? So it is n into n star n minus 1 by 2.
Correct.
But in lecture, I thought in previous, I think activity 1 last question there was in which it was asking activity 9.1 last question it was asking if you open it there was a question in which it was n minus 1 into something. Yes, so the answer will be n minus 1 into something. I got confused between that.
Okay, what is this question? Consider a student can mentor another student irrespective of amount of difference in their marks. With this assumption, maximum how many edges a student can have?
Yes, sir.
See, assuming this has nothing to do with that particular question. Okay, to be honest, what is happening? You are mentoring. Who can mentor maximum student?
Maximum marks.
The person with the topper of the class, right?
Yes.
Then as per our data set, we have 30 students. So
okay,
if
sir.
I am a topper, how many maximum students I can mentor?
29.
29. And I can do that for 3 subjects?
Yes, sir.
That's why 29 by 3, I guess that's the answer, right?
Oh, okay. It's different. And
as simple as that. There is nothing else.
No, for the cliques, why it is n minus 1 by 2 then?
Okay, that I will come to. Okay. First of all, have you understood what is clique?
Clique, I got the clique is basically in a I can tell you it's a transitive. If A is teaching B mathematics, then B can teach C physics, and C can teach
no, that is
chemistry.
not a clique. That is not a clique. That has nothing to do with mathematics, physics, and chemistry. Nothing like that. What is a clique? There are some nodes, okay, and if
all are connected, sir.
Yeah, those nodes are connected with each other with direct edge.
Okay.
Then it's a clique. Now this graph, assume this graph, okay?
Okay.
Now 3, 4, 5, 1. Sorry, 1, 3, 4, 5. This just consider this group. Leave that 2 part.
Okay, sir.
1, 3, 4, 5. It's a clique.
Yes, sir.
Why? Because all those nodes are connected with each other via direct edge.
Okay.
So that is a clique.
Yes, sir. Okay.
And now what we are asking is how many edges in a clique of n vertices will have. That means your each vertex has to be connected with if you have n vertices, right? Then each vertex will be connected with n minus 1 vertex, right? Consider this same clique again. 1, 3, 4, 5. How many edges one has?
One has 1, 2, 3.
3 edges, right? Why 3? Because it has to be connected with every other vertex. So if there are 4 vertices, one should be connected with n minus 1 vertices, which is 3.
Yes, sir.
So this one will have n minus 1. 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 So that is what? N into n minus 1.
Okay.
But you are counting same edge twice. When you say there is edge from 1 to 4, that same edge you are counting from 4 to 1. That's why divided by 2.
Okay. Okay.
Understood from where that formula came?
Yes, sir. And if someone asks what is the clique, we can tell where they are connected by
direct edge. Direct edge. Not directed. Direct edge. See why I say directed edge. See, now you will say 2 and 4 are connected.
But they are
3. But they are not connected directly. That's why 2 is
there
not
is
part
no
of
direct adjacency between 2 and 4 in this case.
Yes, that's why 2 cannot be added in that clique. Clique is just 1, 3, 4, 5. 2 is not part of that clique because 2 is connected only to 3 and 1. 2 is not connected to 4 and 5. If you add edge from 2 to 4 and 2 to 5, then 2 is also part of that clique.
Okay.
Got it?
So 2 to 4 are undirect. Connected under.
Not undirected. You know the word undirected and directed are with different points. Edge has some direction on it. We write some arrows sometimes to the edge, right?
Yes, sir.
That is directed or undirected. 2 and 4 are connected via 3 or via a hop.
Okay.
With an intermediate node, they are connected. They are not connected with a direct edge.
Okay.
Okay.
Okay. Okay.
Yeah.
Thank you, sir.
Okay. Thanks. Okay. It's 10 o'clock. maybe one last question if somebody has. If not, then we can close. Yes, anyone has any questions, any doubts? All right, then. We'll
Sir,
start.
no, if no one has an, may I ask, sir? I have.
Yeah, sure.
So in the same question, actually I got through it, but in the same thing, the undirected and directed thing in the lectures also I was having this much. In directed, I saw there was connection, there was arrow between. One is going to 3, so there is a direct arrow. And that is both sides. When we get both side arrow, then we cancel out the arrow and write it just like it is a 2-from motion between them.
Correct.
So 2 to
when I say 2, 3, there is a edge, right? That means you can go from 2 to 3. At the same time, you can go from 3 to 2 because there is no arrow. That means you can go from either direction to other direction.
Yes, sir. And also there was in the lecture, there was many terms explained, such as edge was there, and many terms were there. So these questions will be asked, such theoretical questions.
No, don't. Okay. But but don't ignore those terms. You should know those terms, and those terms will help you in upcoming courses.
Okay.
Because nobody will explain you those terms again to that detail in upcoming courses. That time, I mean, we'll simply assume, right, that you already know. So do not skip those terms. If you are confused about any of those terms, maybe make a list of it.
Okay.
And if you are not able to understand any of those terms, maybe next session or sometime, or maybe on forum or something, just post a question accordingly that please explain me so and so term. We'll explain you.
Okay.
I mean, right now I don't think you have that list. If you have, maybe I can tell you right now itself. I don't mind. But if you know some terms which are not able to understand, I will explain. Or else maybe you can come up with that list of terms in next live session or post it on forum.
Okay, sir. And also some questions
of that sort now.
No, sir.
I have.
Yeah. Okay. So maybe next time you can come up with that, right? I'll explain.
Just one thing, sir. When you come next time, sir, is it possible, like, see, whatever the pseudocode which is discussed in lesson 10.3 or 10.4, do you have any slide which can show us the step-by-step build-up of this matrix or the dictionary, sir?
No, right? Because it's not possible. The entire thing setup is for the train data set, right?
Yeah, at least, I mean, take 4 stations or something and we go through that dictionary step by step, how it is building up. So I know it is kind of a spoon feeding or something, but if something is there like that, it will aid us in understanding the things better.
Yeah, sure. We can try something like that. Are you there on that Telegram group?
Yes, sir.
Yeah. So from there we announced this on-demand sessions, right?
Okay.
Okay. So maybe next on-demand session we will try to do this.
Okay, sir. I'll keep a note of it.
Is that fine?
Yeah, great.
We'll be taking in this week itself. I cannot assure you about day or something. Some day of this week, maybe Wednesday or Thursday, either of those 2 days. One of us
within the next 2 or 3 days, you mean? Sir?
Yeah, within next 2 to 3 days, we'll be taking one more on-demand session.
Okay,
and
sir.
during that, maybe we'll
where it will be informed, sir?
On the Telegram group.
Okay.
And sir, one more thing, please try to conduct it in evening. Because
yeah. See, that's something. On-demand sessions are not on specific day or time, so it depends on actually our availability. That's how they go.
Okay.
So we haven't even actually decided that who will conduct. If somebody else is conducting, then that person, or else I will conduct. So definitely there will be one on-demand session in next 2 to 3 days, and whoever conducts it, if me, then definitely I will come up with that. Or else if somebody else is conducting, I will let that person know that he should.
Yeah, please, if you can just tell them at least, I mean, any one pseudocode from 10.3 or 10.4, if you can just, I mean, apprise them on this. So it will be easy for us to just do that.
Okay, 10.3 is one hop, and 10.4 is the same thing, right? With just labels.
So 10.3 will be great, sir, if we can do
fine,
that.
fine. That one hop thing with some example of 3-4 stations, right?
Yes, sir.
Sure. I'll ask whoever is conductor, or I'll do it myself.
Sir.
Okay, thank you, sir.
Yeah,
thank you very much.
Is Deepak sir is not taking session from few days, like?
Yeah, he okay. Last few days he was not there. Huh?
Okay,
Maybe. Actually, he was not well for a few days. I don't know. Maybe that was the. I mean, coincidentally, it might have came during the period where he had less sessions. See, actually, what happened earlier, I was on leave for a very long time. So that time, Rahul and Deepak took more sessions. Now I am taking more just to balance it out. So maybe that was the reason. So if that's the case, do you want next on-demand session from Deepak? I will ask him to do it the next.
No,
session.
sir. You can also take it.
Yeah, sure. I think I mean roughly.
No, actually
Deepak,
he was not showing up. That's why I asked. But otherwise, you are also.
Yeah, it's fine. It's fine. Okay, so don't worry. I think actually he was busy with your interim exam paper. So.
Sir, sorry to bring you again, sir, the assignment part. Sir, the last question of sum, I also claim it to be 20. Because, sir, if we are checking about the sum, so if we check by 0, 1, 0, 2, 0, 3, and 0, 4, we will get 1, 1, 1, 1 for everybody of them.
You have to consider 4, 0.
Again, 4 to 0.
Actually, 4 to 0. Yes.
That's where I did the mistake, sir.
Yes.
Consider 4, 0 also.
No, sir, we will consider 4, 0. But then again, sir, if we go to by 1, 0, 1, 2, 1, 3, 1, 4, 1, 5. Okay, again then 4, 0. 4, 0 in every case.
Yeah, every case.
Oh, that's what everybody was talking about. Okay, sir.
Yeah, that's what the whole discussion was going on.
No, sir, that's why I explained to you. Yeah, I was not even understanding a single bit of that. And
see, I'll simply tell you, there are 5 edges.
Yes,
to consider those 5 edges for all 5 nodes.
Yes, sir, I got that now.
It is a matrix, so 5 into 5, 25.
5 into 5. Ultimately, matrix will have all ones.
Yes.
Yeah. Sir, can you tell me that the portion of interim, how many percentages will come from each week?
I don't know. We never announce something like that, so don't expect.
No, every time we announce for quiz, we say that from that week to that week. So that's
yes, week 1 to week 12.
Okay, shall we be more focused on the last 3 weeks?
Yeah, that much I can tell you, but exact percentage, I mean, even I don't know.
Okay,
that's not how I mean. We do not focus on any specific weightage, but definitely more focus will be on last 3 weeks, because we never had any exam on those 3 weeks, right?
Yes, sir.
Yeah. So more focus will be given on that, but that absolutely doesn't mean that we will not ask questions from earlier weeks. We cannot have 100-mark question paper based on 3 weeks, right?
Yes, of course.
That's impractical thing to do. So
that's
there will be questions from previous weeks, but yeah, more questions will come from last 3 weeks. That much I can tell you. Exact number and exact distribution is not.
More meaning like more than 60%.
That's what I said, right? That I can't.
Yes.
Okay. I can't tell you more than what I already said.
Okay.
Okay.
Thank you, sir. Thank you very much.
Yes.
Sir,
thank you, sir.
When the information about BS will come out, like any other?
Yeah, it's already there, right? It's there on website. Detailed specific announcements you will get. We'll also conduct a dedicated session for them. I mean, the operational team will do. Maybe even Andrew sir himself might do it. But there will be a separate session also. After, have you got detailed announcements about that? Not yet, right?
No, not detailed. Just
you will. Just have patience. You are just at foundational level. Why are you so worried about BS?
Yes, sir.
It's a long time for you to reach to BS level. Okay.
Yes,
so don't worry too much about that. It's happening. Yes. Okay.
Sir, I have a query. Will there be any criteria to appear for the last? For the last year,
no, you have to clear all the prerequisite courses. You have to clear BSc level courses in order to start with BS. That's all. There won't be any different other criteria than that. Whatever we have is that.
With any grade,
yeah, most likely. That's what I said, right? We haven't fine-tuned or decided on these small details yet. Just now we got approval for BS. So
Okay.
We cannot do all this before approval. Right now we have approval, so we'll work on these fine details. Right. Once that's the reason we haven't done formal announcement or session yet, because you will ask all these questions and we will not have answers to tell you. So let us figure out all those things. Let's finalize all those things. Once everything is ready as a final thing on the paper, we'll let you know. Okay.
Okay,
it's not a small process, right? Adding additional degree is not a one-day job, right?
Yes,
it takes time, right? So
sir,
we're working on it. See, by end of this, before starting next term, you will have all the details. That much the maximum deadline I can tell you. It will happen definitely before that, but that's the extreme deadline I'm telling you.
Okay.
Yeah.
Okay. Sir, just like before, the total duration for completing this degree is 3 to 6 years.
Right.
For BSc. So
for BSc,
like that for BS, will it be extended to?
Yeah, definitely. It will be extended.
Okay, 2 more years.
Maybe. I don't know. I don't know about those, but it will be extended. That will happen for sure. Otherwise, I mean, it's not possible, right?
Okay, sir,
it has to be extended.
Yeah, because I planned for like to complete this within 5 years. So that's
okay.
What yes.
Yeah, see, it will be extended for BS. It will not be extended for BSc. BSc, it will remain as it is.
Yes.
Yeah. Okay. Yeah. For BS, it will be extended.
Okay.
Okay.
Yes.
All and right. Sir,
is there any duration to complete the diploma like BSc? I think it's not there.
Specifically diploma, huh?
No, I enrolled for BSc degree, but
no, then the total cap, whatever you said, right? If that's there, then it's there. You have to decide. You have to subdivide that into diplomas and foundational and degree level and so on.
No, sir. Suppose I completed my diploma. I took 5 years to complete diploma, and then for degree level, I'll take 1 year. Will it be possible?
If all the courses add up that way, then it's fine. We do not decide on this particular. I mean, we do not have any problem against that. In 1 year, then we have to see how many courses are there in degree level. Is it possible to complete all in 3 terms? Because there is some prerequisites will be there, right?
Yeah. If you take maximum courses, then the minimum required time to complete that one year, like that degree level is, I think, 1 year.
Okay, that is fine. But the point is, if there is some prerequisite, right, then you may not able to take courses in that order, right? That's the problem.
I think there is not. I think there is not, sir. Because
okay. Maybe I see. I don't remember all these fine details at operational level. So maybe if that's the case, yeah, it's possible. See, from our side, we will not stop you to do this 4+1 thing. Or 5+1, as you said. Whatever the maximum is told you, that we will be strict on.
Okay.
In between that, how to span it out between diploma, degree, and foundational, that's up to you.
But sir, for diploma, minimum time is like 1 year and 4 months, I think. So.
Is it mentioned like that?
No, not mentioned.
Minimum, right? Minimum.
Okay.
Minimum. That's because of prerequisites and how many courses you can do.
Yes.
At the same time, your CCC will also come into the picture. All these things are there, right?
So let's suppose, sir, it's a 3-year program, and if they complete like 3.5 years, so it will give any negative consequences on
nothing
our
like
degree.
that. Nothing like that.
Like we go to do the MTech, so they will ask, no, okay, why you do take extra 6 months?
No, over there you are taking extra 6 months. Here you are not taking extra. We are giving you that flexibility. We never said that this term has 4 subjects. Over there, for every semester there are 5 subjects. That's how the standard curriculum is there across all universities, right? We do not have that pattern. We never say, okay, this semester we will teach you 5 subjects. We do not do that. We teach you all subjects. You have that flexibility. This is you should not compare this with other way of teaching in most of the universities, right?
Okay, got it.
Even in IITM, I mean, I had to consider other university. Even in IITM on campus, even BTech we consider, right? Or even other BScs, MScs, PhDs, whatever we consider, right? There are fixed courses which you are supposed to take for that particular semester.
Yes, yes.
And number you cannot reduce.
Yes, yes, got it.
That flexible, that constraint is not here. That we do not have that. You should not consider it that way.
Okay.
Sir, is there any external resource for computational thinking which we can refer to get in-depth knowledge on this matrices and graphs?
Only the book is there which the same professor wrote.
That computational thinking by Professor Madhavan and Professor Venkatesh.
Yes.
It doesn't cover anything about this graphs and matrices.
Yes. Actually, I have gone through
it's
the
empty.
PDF.
I got that media and it is after page 161. It is empty. Nothing.
No, I will tell you the reason is that's that's not the book. That's not the whole book. That was some in order to I mean. Before the book was released, they released that as a teaser or something for first 4 weeks. So that is only for first 4 weeks, which they release for free.
So which means if we buy this book from Amazon or somewhere,
then you will have entire thing. Then you will get entire thing. That's more like publicity kind of a thing for marketing purpose or something like something like that sort. See, they were in the process of writing that book, so we released that as a not even version 1. We released that as version 0.1. So there might even be some slight mistakes here and there. I mean, nothing serious, but some minor things here and there might be there. That was not even released formally or released anywhere. It was just shared with all our online degree students.
And even that website is not live now, no sir. Website of Professor Venkatesh, where we have this practice things and all those stuff.
I'm not sure. From where you got that link?
It is, I mean, mentioned in that book itself. I mean, when you Google that book, we can go into some, specific online portal, which Professor Venkatesh is a part of, where you have all those practice assignments, examples of all those stuff. It's like a subscription-based model, I think.
Oh, okay. Then if it's there, then you might subscribe to it. I'm not sure of that. See, actually, he used to do lot of experiments with computational thinking as a subject with lot of school kids.
Okay.
I mean, not first and second standard kids, but so, I mean, at school level, even in 11th, 12th junior college students and so on. He used to do a lot of experiments, and that material might be from that time. It might be something directed towards that audience.
Yes, sir. Yes, sir.
I'm not sure how much it will be helpful for you guys.
Okay, sir. Okay,
Okay.
Anyway, sir, thank you so much. This session has been really and wonderfully productive.
Yes, thank you.
Thank you, sir.
Yes, sir. Same, sir.
Thank you.
Thank you very much, sir.
Everyone.
Good night, sir.
Good night.
Thank you, sir.